tremendous business value in real world. What I will do is I will take one example where I actually work out a simple data analytics model. This is a fairly simple problem, but it should give you an idea of the importance of data analytics. For the rest of them, I'll just explain to you the case studies. I will not work through a model. This one is a classic problem faced by investors, whether you are a hedge fund or a mutual fund or a individual interested in investing in stock markets. Let us say you are looking at the three different kinds of stocks. The names of the stocks are green, red, and white. Let's say each stock you have studied the past behavior of each of these stocks, and you found out that there are 6 possible outcomes for each of the stocks. So the green one, if I invest 100 rupees, it can make it in a year 80 rupees, 90 rupees, 105 rupees, or 110 rupees, 120 rupees, or 140 rupees. Red, again, the 100 will become 6 rupees. I'm just showing you the factors in the columns. So for the green, I have shown you all the columns. Similarly, red also can have any of the 6 possibilities. Similarly, white also can have any of the 6 possibilities. Let us say, for simplifying purposes, you identified from the past data that there is an equal chance that any of them can happen. So in a given year, the outcome could be 1, which means green will reduce. If you invested 100 rupees in green, it would become 80. If you invested in red, it would become 6 rupees. If you invested in white, it would become 9 rupees. If the outcome is 2, then accordingly the values will change. There is an equal probability that the outcome could be 1, 2, 3, 4, 5, or 6. There is an absolutely equal probability. There's no bias there. But when that outcome happens, we know exactly what would be the give outs or payoff from green, red, and white investments. The question is, knowing all this, in what stock should I invest? I will not be asking for a hand count in this webinar, but typically whenever I ask in any in-person webinars, normally around 50% of the people or 60% of the people will choose green. There is a definite 30% of the people that are risk prone, they are aggressive, they say they will go for red, and a small percentage do want to go for white. I don't know why, because white is almost, it's boring. Most of the times it doesn't change, it doesn't give any more or less payoff, it just keeps your money as it is. But there is some good spread between green and red. I want to actually work out this problem using a technique called Monte Carlo technique, we don't worry about what the technique is. It's a very simple code that I want, analysis that I'm doing. Just walk with me. It's fairly simple. I do know that quite a few of the attendees are fairly senior, so I will keep the coding part to bare minimum. But this is this code is written in a environment called R, the English alphabet R. It's a very, very powerful upcoming data science software. It's very simple also. Here what I'm trying to do is I will create, I will say, hey, let me randomly do these experiments. Let us say I am interested in which is the best choice if I want to invest for 20 years. I'm interested in a long-term investment. So I'll say, hey, there are 3 options you have given me, green, red, and white. What is the best choice for me to apply if I have a 20, if I want to keep the money for 20 years? What I do is I will conduct one experiment. You can think of it as random outcomes. I'll say, okay, randomly let the outcomes be decided and see which at the end of 20 years which one has more or less. But if I just do it once, there is a very good chance that that is not a regular normal outcome. That's an abnormal outcome. So what I will do is I will do 1,000 of those 20-year experiments. So I will randomly say in next year what will happen, year 2 what will happen, year 3 what will happen, like that for 20 years, and compare what happened to green, red, and green, red, and blue. And then I will do 1,000 such experiments and take an average of that and see which one does best. Here I will just run the code. Those of you who are interested in the code, I can share it with you, but it's not very important. To follow this webinar, let me just run the code here. Essentially, you can see that in the code, I am doing 1,000 experiments here. In each experiment, I am running for 20 years. And I am randomly picking any outcome between 1 to 6. As I said, there is an equal probability. I am randomly picking, and I am seeing how much will green give, how much will red give, and how much will blue give. And I am storing them. Finally, I am taking an average of green, red, and blue, and I am going to plot them. So that's essentially the experiment that I've seen. What it tells me is that on average, if I invested 1,000 rupees, green gives me 2,992 rupees, and red, it looks like a good choice at this point. When you look at it, you know, there are only 2 occasions where it is very, very low, but most of the times it's giving 3 times my returns. Quite a few people choose red. But essentially it happens so that red is a disaster. Red gives an average of 27 rupees for my 1,000 rupees in 20 years, and blue gives me 970. My 1,000 remains as it is, but green is the best that I have, 2,992. This is one good indication of why one should go for systematic simulations and analysis in quite a few of these decisions. Now let me actually consider another alternative which was not at all possible, where I actually start, when I start with my 1,000, I will put 500 in green and 500 in red. Instead of putting all my money in either green or red or white, why can't I do 500 in green, 500 in red, and at the end of the year, I will, whatever money I got, I again redistribute such that 50% is with green and 50% is red. At the end of 3rd year, I keep readjusting like that. So at any given year, I hold 50% of my money in green and 50% of my money in red. And when I run that model, I just added a new outcome called pink outcome also. Pink is where I'm putting 50% of my returns, my money in green and 50% in red. I'm just doing exactly the similar model with a 4th alternative. I am now in my R environment and I'm running this analysis. I just want you to take a good note at the bottom right hand side chart. It will take a couple of seconds for you to for your screen to get refreshed, but this is fairly an amazing result that you should take your time to absorb. And this is a problem that people in investment face day in and day out. As you can see, while green gives makes my 1,000 3,000, red is a disaster as it is 27 rupees. A combination of those two makes my return, my 1,000 rupees, 19,423 rupees. This is an amazing improvement in my yield. And you know, I blindly took 50 green and 50 red. Maybe 60 green and 40 red would have been even better. There is a more systematic way of solving the problem, but that's not my intention. My intention is not to show a quadratic programming to solve this problem systematically. My intention is to indicate to you the power of analytics. In a simple day-to-day example like this, the decision with analytics can enhance the returns by probably 600%. This is not an abnormal result. By suitably adjusting, one can get phenomenally interesting phenomenal improvements in returns or lowering of risks. Anyway, that's one problem where I just wanted to walk you through the analysis. However, I would like to take you through a few more case studies that have that are very, very important in different domains. Many of these case studies are where I was part of, so I can confidently say the kind of ROIs that were obtained. This is a case. This is a problem that a the certification company faced. Any ship that is sailing in the waters has to get certified by a few, there are a few authorized agencies that have to certify that the ship is waterworthy. Now, this company that certifies has their offices in 80 different countries and 1,000 different ports. People speak 80 different languages and their age groups are between 20 to 60. And when they have to certify a ship, they go into an engine room, which is this stuffy small room with lots of mechanical equipment, and they visually note down, hey, there is a corrosion on the top of the shell, there is a crack at the bottom of the steering, etc. And they come back and they send the reports into a central repository. They upload the reports into a central repository. But what you have to note here is it is a highly unstructured data coming with lots of spelling mistakes, lots of problems. The goal here for the shipping company is to, the customer, when they come, they ask questions like, hey, is my Boeing engine likely to fail, or my Honeywell engine likely to fail in sea waters after 3 years of commute? To answer that, previously what they were doing was to run several meta searches, collect 1,000 to 2,000 documents that they believed would have the required information, and manually do all the statistics and produce the result to the client. It was taking around 160 to 180 hours by 4 or 5 people. So it's a 4 to 5 human month problem that they were solving. What they asked us was to solve it using analytics. What we did was to build an engine that went through all these records and unstructured data and tagged them on around 20 different variables. Hey, this particular record is talking about this particular defect, which has 20 different variables. It's talking about fracture. It is a 1987 ship. It is engine is made by Boeing. It is talking about this other thing. So we actually were able to tag it. After tagging, the delivery time came down to from 160 times 4, 640 hours to around 0.3 minutes. It's a phenomenally phenomenal improvement in the productivity. So text here we combined, if you look at it, there is the data preparation, unstructured data into structured data, and then classification. Does it belong to corrosion? Does it belong to failure, fracture, etc. on multiple variables? This is another interesting application for companies that are in telecom or healthcare kind of